Welcome back. I'm Professor Steele, and today we are going to look at transformations of sine and cosine functions. We have several examples to look at. The first one, if you notice, takes cosine of theta and then subtracts 1. And if you recall from transformations in regular functions, if we take a function and subtract 1, what value is that affecting? Yes, you are correct if you said the output. So everything has been shifted down. This is a vertical shift down 1 unit, since it's affecting the outputs. Second example, j of theta. This time we have our function sine with theta plus 1 in parentheses. If you recall, anytime we add or subtract a number to the input variable and then apply a function to it, we are affecting our input values. And if you recall, it is always the opposite of what it appears is happening. Theta plus 1 actually has a horizontal shift, not right, but left 1 unit, as seen in the visual. Third example, m of theta, 3 cosine theta. Recall that any number in front of our function simply magnifies it or minimizes it by that factor. In this example, we have stretched our function. Which way? Vertically. So we have a vertical stretch by a factor of 3. It's very important that you state by a factor of 3 and not just vertical stretch of 3 units. Vertical stretch of 3 units would just mean it moved up 3. But when we say by a factor of, we're talking multiplicatively. We've stretched everything, as you can see in the diagram. Fourth example, p of theta equals negative sine of 2 theta. We actually have 2 transformations happening here. The first one, the negative in front, anytime you have a negative of your existing function, we are simply taking our values and making them the opposite. If our negative is in the front and our function values were positive, they would become negative. If they were negative, they would become positive. So we have a reflection vertically. So we have a vertical reflection. The 2 theta inside the parentheses, again, inside parentheses affects the input. This tells us that everything is happening twice as fast. So if you think about our output values occurring twice as fast, that would mean all our input values smushed. In other words, it compressed. If we're getting those values twice as fast, it would take half the time. So this actually is a horizontal compression by a factor of 1 over 2. It's always by a factor of the reciprocal of the number. So if this number was 0.5, in other words, it's going half as fast, it would take twice the time. So this particular example has 2 separate transformations occurring. If we look at the general transformation, that tells us what is being affected by each one of these values. Our A value affects our amplitude. Our B value affects the period. Our C value tells us how much we've shifted horizontally. And our D value tells us how much we shifted vertically, which affects our midline. We're going to use those features in our upcoming video, which looks at a thinking problem that incorporates all of these in an expansive problem. Thanks for watching. I hope this helps. We'll see you next time on EdVantage.